let's see, who's an equivalent here?
I could see Ivy.
I was thinking Kai. Kai was like quilting.
every
Okay, so
day.
Kai's making quilts
Meredith makes
and goes to this place, I think it's called Michael's, to buy some quilting fabric. It's two
I
colors.
own Michael's.
Let's say the colors are yellow and brown, your favorite, right, Kai?
Oh.
So, I just needed a light and a dark. That's the first that came to mind. Not too dark a yellow, though. Anyway,
Why brown?
he's buying 9.5 yards, at least 9.5 yards of fabric. At least. But Kai's on a budget. Kai only has $110 he can spend on the yellows and browns, okay?
Man, you broke.
So here's two graphs, and here's what you're going to do. So, what you're going to do with your partner is this. Write an inequality to represent the length constraint. Test out those ordered pairs. Then you're going to write an inequality to represent the cost constraint. Test your ordered pairs. And then answer questions 5, 6, and 7 with your information. So get after it with your partner. All right, so I'm going to ask for some help here. Who can tell me what the constraint would be for length of fabric? Vinny, you got it?
Oh wait, length for fabric?
Yeah, number 1, the length.
Oh wait, I don't think we.
All right, someone else got the length for me? Ava.
Y plus x is greater than or equal to 9.5.
Yeah, we need at least 9.5 feet total, right?
I did X.
So here I got 10. Does 10 work?
Yep.
Here I got 7. Does 7 work? Here I got 11. Does 11 work? And here I got 22. Is that enough?
Yeah.
Okay, all these work. These all will get us at least 9.5 yards, okay? Now I need the cost constraint. What's my cost constraint? Yeah, Olivia?
9x plus 13y is less than or equal to 110.
Yep. So $9 per yard of the light plus $13 per yard for the dark needs to be at or under $110. So we're going to check these prices. One of each. Does that keep us under 110?
Mm-hmm.
So 36 plus 65. Does that keep us under?
Mm-hmm.
This one does? Let's try it. 36 plus 65.
It's exactly 150.
101.
No, it's not. Oh wait, I thought it was 35.
3, 4.
I agree with that. Yeah, it's
101 stays under, right? So that works. What about 8-3?
No. Absolutely.
That'd be 72 plus 39. Nope. What about 10-1?
Yes.
9?
Yes, it does.
Yeah, that does work.
103.
90 plus 13 is 103. That's
Partially right.
at or under 110.
I'm gonna put peace.
Now let's talk about 2-2. Okay? Everybody's favorite formal wear. Okay? A 2-2. So, let's put that in. Which one does that not work in, like, slam dunk for sure? You don't even have to do anything. Length. Because this only gives us how much? 4 yards, which is not more than 9.5 needed. Now, could we afford 2-2?
I just made an arrow in
18 plus 26. Could we afford that?
Yeah.
That'd be $44. We got plenty of cheddar for that, man.
Mr. Mac.
So we can afford it, but it is not long enough for Kai to make his quilt. Okay? So who's got some that, I'm going to write it on this previous page actually. Now I want some of these ordered pairs that work for both. All right, what are some ordered pairs that work for both constraints? Give me one, Ivy.
I don't know if this is right because it's decimals and you like it's in the thousands, but like
Sure.
3.375 for x and then it's 6.125 for y.
That's one of them.
Okay, who's got another ordered pair that would work for both? Rap?
8 and 2.
8 of the light, 2 of the dark, okay. Vinny?
5 and 5.
5 of each, okay. That gives me 10, so we'll check that out. Let's do one more. Who's got one more that thinks going to work?
Does that work?
JP?
Yeah, there's one. No, it doesn't work.
2, 1. Okay, let's check these all out. So the thing I'm going to choose to do is I'm going to put both of these graphs on the same graph. Check it. I'm going to put the graph from B onto A so I can look at them at the same time. You guys see what I'm doing here?
Oh my god, it's exactly that. 5 times.
Let's see. There's that. And it's shaded underneath. So what area is going to be shaded by both? You guys seeing this little triangle right here? And do the lines work? Are the lines solid or dashed? Solid, so the lines work. So let's check out these points. So I've got something around like 3, 6. So that's going to be 3, 4, 6, 3 something, 6 something. It's pretty close right there.
Yeah, 6 will be right on the
Did that
line.
work
It'd be
right
5.
on it? When you got that was like exactly.
Yeah, so it's 5-5.
Oh, you know what you found? I know Ivy did. You did the system of the lines, and since it's or equal to for both, that is
No, Vinny, I think 5-5.
that works. Okay, let's
No,
test
it's
8
10.
2.
It's 110.
8 2 is right here on the line, just over the line. That works. Let's test 5 5.
Right on the line.
5 5 right on that line. That works. Let's test 2 1. Okay, down here. So 2 1 failed the length requirement, right? That's 3 yards. We need 9.5. That's good.
You guys please stop laughing.
No, it's good. That's a good mistake. So, big idea here is we need to satisfy multiple constraints. That's going to happen where the 2 constraints overlap. So before, when we had linear equations, it's where the 2 lines crossed. They're just lines, right? These have whole regions that are going to potentially cross each other, and that's what we're looking at to get solutions with today.
Wasn't on the line.
Okay, so there's going to be 3 situations. Different groups are going to take different situations. So groups 1, 2, 3, 4, you're going to take the bank accounts. 5, 6, 7, 8, you're going to take concert tickets. And 9, 10, 11, 12, you guys are going to take advertising. You're all going to work on the same problems on the bottom of your notes, 1, 2, and 3. But different tables are going to do different situations, okay? So for the banking one, what are the constraints? That would be groups 1, 2, 3, and 4. What are the banking constraints? Give me one, Josiah.
S, which is the savings account, needs to be greater than or equal to 50.
Okay, I think in the situation it's Y, but either way will be good.
X plus Y has to be
And-
less than or equal to 50.
X plus Y has to be less than or equal to 600, right?
Yeah.
Okay, so let's zoom out. So let's talk about what the solution is here, okay? The red is at least 50, right? Everybody see that? The blue is the 600 or less. So the places that satisfy both constraints would be this purplish region where they cross. Now this is theoretical over here, and it does work on the left there. Oh, I didn't realize you can't see that on my iPad. One sec. So we'll do this. So anywhere on this line does work. That's $600, and that is more than the 50. This is all the 50, even though it's less than $600. This is theoretically right, but we wouldn't have like negative money in one of the accounts. Okay. So the answer in this case is where the 2 overlap. Let's look at the next one. So you guys got points, showed that the points were in that area, right? The next one was not advertising. What was the next one about? Oh, tickets to the concert. So that'd be the next 2 groups. Troy, give me one of the constraints. So they can only have to have less than 400 tickets. I'm doing X and Y because this won't do LNS, but I like that organization. And then what's the money one? Someone over here. Brendan? Oh, no, that's not you. That's not you. That's you, Maddie? So they need to make at least $14,000 if it's $30 for this ticket, $50 for this ticket. So let's look here. Where the green and the purple cross would be in this region right here. I forgot that it doesn't. This region right here, right? Now, if we landed on this line, does it work?
No.
No, because this line would be $400. Or sorry, this line would be 400 people. And we can't have 400 people. We have to have less than 400. What about if we're on this line?
Yes, because it's...
That's $14,000.
Greater than or equal.
What about this point right here?
No.
It's on the line.
No, because that's on the dash line, which would not meet that requirement, right? So anywhere in here. Now, again, this theoretically works, but we wouldn't have negative tickets. So we're operating in this region right here. So if you pulled those ordered pairs, you would just need to make sure it's from this region right in here.
Something like 100.
Yeah, it can be lots of things. Advertising. What's one of the constraints for advertising? Give me one, Ivy.
1,000x plus 2,500y is greater than 60,000.
So they need to make more than 60 grand. Okay, and then what's the other constraint? Yeah, Lou.
X plus
So they're going to sell 60 or less? Is that what that means?
No,
Oh, equal to.
Less.
it's at least 60, not.
So greater than or equal to?
Yeah.
Okay. So they need to sell at least 60 and they need to make at least 60 grand. So this is what we're looking at here. So everywhere in here is going to be an answer. What about on the line right here? Does this work?
Yes.
Yes, that's solid. That means they made 60, they sold 60, and then all the dollar amounts over here include things that make over $60,000. Now again, this is theoretically works down here, but we're not going to have negative sales of advertising packages, okay? Cool. Next up, treasure hunt time. Let me get back to where we're at here. You'll see. Present. So this school is having a treasure hunt, and you're more successful finding the treasure if you get in the correct area. They're giving you an area to search in if you can correctly shade these inequalities. So you're going to graph these. 4 different clues. Just look out. One clue has no solution. All right, y'all, let's do it to it. I got y is greater than 14. That's going to be this dashed line right around here. Because does 14 work? No, but everything greater does. And then I got x is less than 10. So that's this dashed line. Does the line work?
No.
But left is less. And I do this thing called like a cross hash thing. Do you see how like the vertical and the horizontal shading kind of like gets you up in this corner? And then I'll go after and just really make that tight, right? So that area right there is all. That's where we know we can find the treasure for that clue. Okay, there's a treasure up there. I'm pretty sure. All right, next one. The intercepts are both 20. The x-intercept's 20 and the y-intercept's 20 for this, right? When x is 0, y is 20. When y is 0, x is 20. That needs to be dashed. And does the origin work? Is 0 less than 20? Okay, so I'm shading below. And then x needs to be greater than 6. So does 6 work?
Yeah.
Greater than 6? No, 6 doesn't work. So everything this side, and where they cross is in this region here. So right down there. So that's where we can find the price. This next one has a y-intercept of 20, a slope of -2. Does the line work? Nope. Does the origin work? Is 0 less than 20? Yep. So down there. The next one has I'm going to do this next one a different color. Let's do this. The y-intercept's 10. The slope's -2. This line also doesn't work, this yellow line. But everything below it does. So I know it has to be in this region down here.
That's where the treasure is.
What's kind of cool is, does it matter where it is compared to the first line, kind of? No, it's all just under the second line. That's the only place they overlap. Last one. I've got a y-intercept of 10 and a slope of 1. Solid line because of or equal to. And then I'm rewriting the second one like this. I just like y on the left because then it's in like slope-intercept form. So my y-intercept is the origin. My slope is 1. That has to be a dashed line. Oh, I forgot to shade the first one. For the first one, does the origin work? Is 0 greater than 10? No, so I shade over here. The second one, I can't test the origin. Let's test point 10, 0 right there. Is 10 greater than 0? Yeah. So I have to shade that direction. So where do they cross on that last one?
Nowhere.
No solution. Right? Sounds like a nightmare for somebody with contacts.
Actually, you wear contacts.
See? No solution, man. Just imagine.
Yeah. And they would be.
All right, that's it, friends. Here's everything we know how to do.
Then you're.
We can write a system. We know what it means where the solution to the system is. It's where the shaded areas cross. And we focus on solid lines versus dashed lines being answers versus non-answers.
You don't.
Let's go.